Teeny, tiny hiding spots amongst teeny, tiny mineral and organic particles in soil are the perfect homes for harmful diseases. Should you be concerned? We're going to be tackling this question and more in this segment. Welcome to Isthmus, the auditory content for the University of Wisconsin-Madison's Journal for Undergraduate Science and Technology. I'm Adrian Sieck. I'm a writer with Just and a resident soil science student. I like to talk about soil. Sometimes people wonder why I chose to study soil science or what sparked my interest. I always share with them my favorite soil fact, that there are more microbes in a teaspoon of soil than there are humans on the earth. Is this universally true? Well, it does vary soil to soil, but the fact's been passed around by many reliable sources, so I'm taking it as gospel. In any case, it stands true that soils are rich with microbial life, including fungi, bacteria, and viruses. Aren't bacteria and viruses both things that can make us sick? Not all of them do, but this is true for some. For better or worse, some human and animal pathogens can survive in a soil environment. According to the Journal of the American Board of Family Medicine, a variety of human diseases can be contracted from soils. Bacteria, fungi, and viruses are found in droves in soil environments. Bacteria are microscopic, single-celled organisms, smaller in comparison to multicellular fungi. Unlike bacteria and fungi, viruses are not cells and they rely on organisms to multiply. What diseases could we expect to find in soil? According to the CDC, the bacterial disease tetanus is not common, but those who catch it should be hospitalized due to its severity. Symptoms include muscle spasms and stiffness, seizures, headaches, and fever. Botulism, known for the risk of catching it from improperly canned food, is also an uncommon and risky disease. Botulism can lead to paralysis, difficulty breathing, muscle weakness, and blurry vision. Switching to fungal diseases, coccidioidomycosis, also known as valley fever, doesn't occur in all people exposed to the fungus, but it can cause fatigue, coughing, fever, shortness of breath, and aches and pains. While these diseases can sound scary, not all pathogens are easy to catch. Many of them are only really a risk if actively ingested or in contact with an open wound. Tetanus and botulism are considered the easiest to catch through inhaling bacterial spores. Fungal diseases are largely caught the same way. Other diseases, however, pose a risk if you eat or drink contaminated food or water. Considering the relationship between soil and water, the line can start to blur between what is considered a soil disease versus a waterborne disease. So, you know that diseases can be caught from soils, but we have yet to identify the mechanisms. To better understand what might influence the infectivity of soil diseases, we can look at a study on chronic wasting disease, a prion disease that can infect deer, elk, moose, and caribou. In 2014, a study conducted by Kuznetsova et al. Found that the infectious agents of prion disease were better hosted in soils with smaller mineral particles. In fact, a study in Colorado found that for every 1% increase in soil clay, there is an 8.9% increase in prion infection odds, clay being the smallest mineral particle size classification. Why would particle size impact the ability of soil to host prion infectious agents? Interestingly, the size of a soil mineral particle has a large effect on the properties of that particle. While sand is basically just ground up rocks, once you get down to teeny tiny clay particles, more interesting things start to happen. We all know that clay is sticky. You can imagine clay that's used for pottery. This stickiness comes from the high surface area and charge that clay particles have, helping them attract water and positive molecules, as well as bond to organic matter in soils. Organic matter can also bond to infectious agents, but the mechanism of bonding is still relatively unknown and requires further study. Other than the particle makeup of the soil, the study also found that the ions in the water could make a difference in the binding activity of soils. Considering the role that charge has with clays and infectious agents, the presence of differently charged ions can create new and interesting interactions with charged particles like clay. Manganese, for example, has been shown to potentially increase the infectiousness of prions when associated. Given the role of microbial life in soils, as well as the microclimates that soils provide for them, it's no surprise that diseases can be found hiding underground. While the study on prion disease is fascinating, it's probably best that we humans don't worry too much about catching it from proximity to soil. We can all stay safe by drinking clean water, cooking with proper hygiene, and avoiding inhalation of soil. I hope you enjoyed this segment on soil science. To finish off, I'd like to thank Just's sponsors: the Associated Students of Madison, College of Agricultural and Life Sciences, Wisconsin Institute of Discovery, Wisconsin Alumni Research Foundation, Dr. Todd Newman, and Dr. Joan Jorgensen. Thank you for listening. Be sure to find our printed journals across the UW-Madison campus at the end of the semester. I'm Adrian Sieck with another segment of Isthmus.